Hello guys, today we are going to talk about equations. To talk about equations, we have to keep in mind that an equation is similar like a scale balance. An equation expresses the equality of two mathematical expressions. In a similar way, the scale balance shows us the equality or the equal weight in both sides of the scale. Talking about the equation, that expression that we are comparing, that they are equal, can be either numerical or variable expressions. Also, it's important, guys, remember that a solution of an equation is a number that, when you substitute for the variable, result in a true equation. Okay, then let's analyze some examples. Okay, then determine whether a given number is a solution of the equation or is not. Then let me provide first the equation. Let's consider this equation. 2x plus 5 is equals to x squared minus 3. Okay, then this is one part of the equation, this is the other part of the equation. Left part, the right part, like a scale balance. Okay, they are in balance because the signs say that they are equal. Okay, then that's important. Then if we have to find the solution of this equation, is because we have to find a number that, when we replace by the variable, the result in both parts, the left part and the right part, is going to be equal. But in this case, we are determining if the given number is the solution or is not the solution. Then let's use this example, or let's use this number. Determine if 3 is the solution for this equation or is not the solution. Remember, if we are determining if 3 is the solution or is not the solution, the first step is replace each variable by 3. Then let's replace 2 times x, in this case 3, plus 5, we're replacing, equals x squared. Then remember, x is 3 for now, we are considering that option replace. Now operations, 2 times 3 is 6, and put the 5 down. 3 squared is 9, and put the 3 down, minus 3 down. Now 6 plus 5 is 11 on left, and on right 9 minus 3 is 6. And we can notice here that 11 is equals to 6, but obviously 11 is not equals to 6. 11 is equals to 11, and 6 is equals to 6. Then what does it mean in this case? This means that this is wrong. Then 3 is not the solution of the given equation here. It's not the solution. Now let's consider, or let's analyze another situation. Let me erase. Okay, now let's analyze this case. What if we are supposing, or we have to prove if the solution of the given equation is negative 2? Okay, then that means that we have to replace now every single variable by negative 2. Then it's 2 times x, 2 times negative 2, plus 5 equals x squared, then negative 2 squared minus 3. I'm just replacing by negative 2, trying to determine if it's or is not a solution. Now operations, 2 times negative 2 is negative 4, put plus 5 down, equals, in the other side is negative 2 squared is positive 4, minus 3, put it down. Now on left, negative 4 plus 5 is positive 1, and on right 4 minus 3 is positive 1 too. Now we have here that 1 is equals to 1, and obviously that's right. 1 is equals to 1. That means negative 2 is the solution of the given equation, this equation here. Okay, then really simple. If you have to determine if a given number is the solution of an equation, just replace the number for each variable, and you have to determine if we get exactly the same numbers on left and on right. If happen like this, then it's because that's the solution. Okay, now let's talk about solving equations. Remember, solving equations is find that number that, when you replace, is exactly the same, but not always. We have an options. Sometimes the exercise is asking us to solve the equation, but we don't know, we don't have any option, like in the previous example. For example, let's solve this equation. X minus 4 is equals to 2. Okay, then first compare the equation. This equation form is this equation: x plus a equals b. In my equation is x minus 4 equals 2. Then in this case we have an additive equation, because the only operation that we have is an addition. In here is a subtraction, but remember that subtraction is exactly the same as adding by the opposite. Then it's an additive situation. In this case, the strategy is keep the variable or leave the variable alone in one side of the variable of the equation, in one side of the equation. Then we have to leave x alone on left or right, whatever we want. But the problem to leave it alone is this minus 4. But it's really simple, pay attention. Then x minus 4 is equals to 2. Okay, in here the problem is that we are subtracting 4 on left, but if we add in plus 4 in both sides of the equation, then we can eliminate that problem. And the reason is really simple: x minus 4 plus 4. Minus 4 plus 4 is 0, then it's going to be x alone on left, and on right 2 plus 4 is 6. That means x is equals to 6. Then that means that the solution of this equation is 6. X is equals to 6. But of course we can check the solution replacing. Then if 6 is the solution of the equation, then x minus 4 is equals to 2. That's the original equation, and now we said that 6 is the solution. That means when we replace 6, x by 6, minus 4 is equals to 2. 6 minus 4 is 2, and 2 is equals to 2. Yes, that's true. 2 is equals to 2. That means that indeed x is equals to 6. The solution is 6. Pretty simple. Okay, now let's consider another kind of equation, and the other one is this: the equation of the form ax equals b. In this case, as we can see, the operation in the equation is a multiplication. This is multiplicative property of equation that we have to use. Then let's analyze, or let's consider another example that we can analyze to solve this. For example, solve this equation 2x equals 8. Okay, we can see that the form is the same: a number multiplying x, that is the variable, and is equals to a number, in this case is 8. Then we have to use, in this case, the multiplication property of equation. Then the problem to leave x, or the variable, alone in one side is the number 2. This is the problem, and this 2 is in a multiplication with x. Then we have to fight against this problem with the opposite operation. Then it's going to be division by 2 and division by 2. In both sides apply the same, otherwise we are going to change the balance of the equation. Okay, then 2 divided by 2 is 1. In other words, is just x, because 1x is x. And on right, 8 divided by 2 is 4. That means the solution of the equation is 4. Remember, always we have to check, and the checking is replace the value in the original equation. The original equation, remember, was 2x equals 8. Then if we replace x by 4, according to my solution, the answer must be 8. Then 2 times x times 4, according to my solution here, must be equals to 8. 2 times 4 is 8, and 8 is equals to 8. Yes, that's true. That means that the solution is 4. X is equals to 4, must be equals to 4. That's it, pretty simple. Next case is a combination between a multiplication and an addition or additive. Here, the equation is affected by two operations, multiplication and addition or subtraction, of course. Then let's consider here an example to analyze this case. It's not really hard, it's very simple. Let's suppose that we have to solve the equation 3x minus 7 and is equals to -5. Okay? Negative. Okay. Then solve. Remember, here we have multiplication and we have a subtraction. Then the equation is of this form because we have two operations. Okay, then we have to fight against the problems one by one. First the additive and then the multiplicative. Okay, then 3x minus 6 equals -5. Then the first we have to fight against this -7, then with the opposite operation. Then -7 is +7 on left and obviously also on right. And then operations. 3x is 3x, -7 plus 7 is 0, then it's going to be equals to -5 plus 7 is +2. Then we have 3x is equals to. Now, as we can see, the only problem to leave x alone on left is 3. And 3 is multiplying the equation. Then we have to fight with the opposite operation. Then divided by 3 and divided by 3. Okay? 3 divided by 3 on left is 1. That means that is just x. Because 1x is exactly the same as just x. Is equals to 2 over 3 is 2 over 3. It's a fraction. 2/3. That means my solution is 2/3. We can check by replacing and my answer must be exactly the same. Okay? Then in this example I'm not going to check, but if you replace we can prove. Oh, okay. Or let's check in this part here. Then check. The original equation is 3x minus 7 equals -5. Now let's replace x by 2/3. Then 3 times 2/3 minus 7 and it must be -5. 3 times 2/3, remember that we have to put the number 1 down at the bottom and multiply face to face. 3 times 2 is 6 and 1 times 3 is 3. Minus 7 equals -5. Now let's simplify the fraction. Okay, 6 over 3 is 2 because 6 divided by 3 is 2. Minus 7 is -5. 2 minus 7 is -5 and -5 is equals to -5. Yeah, this is true. That means that this is really my answer. Okay, x is equals 2/3. That's it, guys. Really simple. Now let's talk about some word problems. To solve problems that we know as a uniform motion problems, okay, we have to analyze, or we have to keep in mind some information first. Uniform motion means that the speed and direction of an object don't change. Okay, that's really important. Any object that travels at a constant speed in a straight line is said to be in uniform motion. Then, if we are talking about uniform motion equation, we have to consider this equation. D, that means distance, is equals to R, that means rate or speed, times t. T represents time. Okay? Then that's the situation. Then let's analyze this word problem. A bike goes 3 miles in 45 minutes. What is the rate of the bike in miles per hour? Then the first thing that we have to do is that the equation is asking us about rate. Then we have to find what is R value, and also say that it must be in miles per hour. Then the distance is already in miles because we say the word problem says 3 miles, but the time is in minutes. Then we have to transform from minutes to hours. Then the first is transform or find the time in hours, not in minutes. Then obviously here we have that the time is 45 minutes. But if we have to transform by from minutes to hours, then we have to divide by 60 because we have 60 minutes in 1 hour. Okay, and this is a fraction. If we simplify this fraction, we can determine that the answer is going to be 3 over 4. Then we can simplify this fraction by 15. Then simplify by 15 is 3, and by 15 is going to be 4. That means that the time is 3 over 4 hours. Okay, then let's replace. What is D in the equation? D is 3 miles. Then 3 is equals to R, that we don't know what is the R because that's the equation that we have to solve, times T, and the T is 3/4. Okay, then this equation here is an equation that I explained before, equation of the form AX equals B, when the only operation with the variable is a multiplication here is a multiplication. Then we have to divide in both sides by the same number, or in this case multiply by the reciprocal. It is exactly the same. Then 3 is equals to R times 3 over 4. Then we have to divide by 3 over 4, and here put it number 1 here and divide by 3 over 4. If we solve this division, in here is going to be 12 over 3, and in here is going to be just R, because every number divided by itself is 1. 1R is R. Okay, then let's continue here, and we say that R is going to be 12 over 3, and we can say it here, and R is equals to 4, and that is exactly the equation. Then remember, this is a word problem. Then the solution is the rate of the bike is 4 miles per hour. That's it. Really simple. Then just use the uniform motion equation that we have here, it's always the same, and isolate the corresponding variable. Okay, now let's analyze another situation with the same context, that is the uniform motions problems. In here, then two cars start from the same point and move in opposite directions. The car moving north is traveling at 60 miles per hour, and the car moving to the south is traveling at 45 miles per hour. In how many hours will the cars be 315 miles apart? Then let's remember first what is the uniform motion equation. Remember that equation is D is equals to R times T, or RT. D means distance, R means rate, and T means time. In this case, in this word problem, our question is the time. In how many hours? Then the question, my variable is going to be time, T in this case. Then let's replace the other values. In this word problem, we are analyzing this movement, and this movement is between two cars moving in opposite direction. Then just because the cars are moving in opposite directions, we have to add the distance, or the speed for all of them, the rate for all of them. Then one car is 60 miles per hour and the other one is 45 miles per hour. Then we have in here a speed of 105 miles per hour as a total. be careful. This, we have to add the speed between cars because they are driving or moving in opposite direction. Okay, that's the reason. Then we have to now replace the values. Then in here we have to consider this value 315 miles apart. That's the equation. Then this is my total distance. Then D is 315 is equals to R, that in here R is my speed here, then 105 times T, and T we don't know what is T. Remember that we don't know what is T because that's the question. In how many hours will the cars be at a specific point? In this case 315 miles apart. Okay, then in here we have to isolate the variable. The variable is T. Then the problem to isolate T is 105. 105 is in a multiplication with T. Then we have to divide in both sides by the same number. Which number? 100 and all of these divided by 105, and in here divided by 105, and just solve the operations and the exercise is going to be done. Then let's consider first the division at left. 315 divided by 105 is 3, okay, and in the other part 105 divided by 105 is 1 times T, obviously is T, okay. Then my conclusion, time is 3 what? 3 hours, because time is in hours. Then let's solve the situation. The answer is going to be in 3 hours. In 3 hours, the cars will be 315 miles apart. That's it. That's my answer. Okay, guys, that's all about this word problem. Now let's analyze another word problem that we can analyze in this case, and is this situation in here. Then to the pressure at a certain depth in the ocean can be approximated by the equation P equals 15 plus 0.5 D, where P is the pressure in pounds per square inch and D is the depth in feet. Use this equation to find the depth when the pressure is 55 pounds per inch. Okay, then let's analyze the strategy of the situation. First, let's copy the equation, the given equation. Then in here, P is equals to 15 plus 0.5 D. Then let's identify what we have to do here. Use the given equation to find the depth. Find the depth. Then here, this is going to be my variable. Then we have to replace P. Then when the pressure is 15 pounds, then P is 15 because P represents the pressure. 15 is equals to 55, sorry. 55 is equals to 15 plus 0.5 D. D represent the depth. Exactly what we have to find according to the equation. Look at this. Then let's isolate D in my equation. Let's start isolating by the numbers that are adding or subtracting. Then 55 is equals to 15 plus 0.5 D. Then remember, this 15 here is adding, is an addition. Then we have to subtract in both sides. Then minus 15 and minus 15 in both sides. Minus 15 minus 55 minus 15 is 30. Okay, and actually it's 40, sorry. Let me erase, let me fix my mistake. Okay, then it's 40 equals 15 minus 15 is 0, then it's going to be 0.5d. Now the only operation is divide by 0.5 and divide by 0.5. Okay, this equals to 40 divided by 0.5 is 20. You can use long division to solve the division, and you can determine that it's going to be 20. And 0.5 divided by 0.5 is 1. In other words, is 1d or just d. That means that d is equals to 20. D is equals to 20, and it's exactly the question that I have to solve here. Then my answer, what is going to be my answer? Use this equation to find the depth. Then my answer must be the depth when the pressure is 55 pounds per square inch is 20 meters in this case. Okay, then that is exactly the sentence that I have to copy here. Okay, remember guys, then the depth when the pressure is 55 pounds must be 20 inches in this case, because in the context we are talking about inches, then that's the unit on measure. Okay guys, that's all. Thank you so much. See you.